4. Today we are graphing linear inequalities using two variables. Okay, so we're going to put together our skills of graphing in slope-intercept form with inequalities. Okay, so we know that when we graph a y equals mx plus b, we begin with the b and we move with our slope. Okay, and we know that when we graph an inequality on a number line, that we have shading to indicate that there are multiple solutions. So the same thing is happening here, except being on instead of a number line, we're on a coordinate plane. Okay, and all of the possible solutions are still in the shading. The solutions just now happen to be ordered pairs. Okay, so similar to when we use an open or closed circle on a number line, we're going to use dotted lines now, okay, to graph when it's greater than or less than, and we're going to use solid line to graph when it's equal to. All right, so you can think of an open circle equivalent to a dotted line, and a closed circle equivalent is a solid line. Okay, and that's just graphing the actual equation, the slope-intercept form of the line, and then we'll get to the shading. Okay, so you know that when you graph, you need your equation in slope-intercept form, which means it has to possibly be solved for y. Okay, and then you're going to determine, do you need a solid or a dotted line to connect your points? Okay, and then we're going to shade. So if your equation is greater than, you're going to shade above the line. And if it's less than, you're going to shade below the line. I'm going to show you a little trick with arrows to help. Okay, so here's my first example. Okay, this is clearly not in slope-intercept form, so I'm going to move my x and I'm going to divide in order to solve for y. Now, you have to remember inequality rules. When you multiply or divide to the other side using a negative, you have to flip the symbol. So this equation now becomes greater than. Okay, and if we forget that step, okay, it's going to interfere with the shading that we put on the graph. Okay, so now we're going to use slope-intercept form to graph. So we're going to begin with our b and move with our slope. Okay, and I want you to fill up as much of the graph as you can. Okay, so when you're graphing these inequalities, I want you to fill up the entire graph. I know previously we said we only needed 3 points. We're going to do the entire thing now. Okay, so before you get your ruler to connect these points, you need to ask yourself, is it a dotted or solid line? So you're going to refer to the inequality symbol. Okay, and since that is not equal to, you're going to use a dotted line. Okay, use a dotted line to connect those points. Right, and now we have to talk about the shading. Okay, so if this is greater than, we want to shade above. Okay, so I'm going to show you a little trick. So on your line, okay, you want to put your pencil on one of the points, and you want to draw an arrow that points above the line, and that's going to show you where to shade. Okay, so if you draw these little arrows that point above, well, now I know that I should shade my line over here. Okay, and you've just created graphing your first inequality in two variables. All right, let's try it again. All right, so again, I need slope-intercept form I have to solve for y. So subtract x and divide. Okay, so here is my equation. All right, so let's graph that. So begin with your b and move with your slope. Okay, so I'm going down 1 and to the right 4. And remember, I want to fill up the whole graph. So I'm also going to go up 1 and to the left 4. Okay, and then checking my inequality symbol. Do I want a dotted or a solid line? And I'm going to use a solid line this time since it is equal to. Okay, so that solid line underneath the inequality symbol tells me that it should be a solid line on the graph. All right, and now we have to determine where our shading goes. So this is a less than. Okay, and for less than, we shade below the line. Okay, so my little trick from before, if I put my pencil on the line and I draw arrows that point down for below, that shows me where I should shade. Okay, and then I can shade that side of the graph. Okay, this is a pretty easy topic. All right. Now, x is greater than -5. This is one of your special case lines. Okay, this is a horizontal line. Okay, because this has a 0 slope. So we're going to find -5. Okay, it goes on the y-axis. And looking at my inequality symbol, that says it should be a solid line. Okay, so I want to put a solid line through only the y value of -5. All right, and now that is greater than, and greater says we should shade above. So with your pencil on your line, draw arrows that point above the line. Okay, for a horizontal line, that's pretty obvious. All right, and then we can shade. Okay, so this is really very simple. Okay, so if we have a horizontal line, we can now expect to see a vertical. Okay, so this is a vertical line. Has an undefined slope. All right, so find 2 on the x-axis, and according to my inequality symbol, it is not equal to, so I'm going to use a dotted line. Okay, now this is greater, which would mean above, all right? But for a vertical line, there really is no above or below. So for a vertical line, instead, we want to think, well, on which side of the line are the values greater? Okay, so if this is 2, on this side of the line is 3, on this side of the line is 0, so which one is greater? Okay, it would be to the right side. So the right is what we would shade for that. So that would constitute the above side of the line here. Okay, hopefully we're doing well. If you want to pause at this point and get all of your graphing finalized, we're going to move into a different type of problem. Okay, so now we want to just determine what is the inequality from this graph. Okay, so we want to work backwards. All right, so I see that this is a vertical line. And hopefully we know that a vertical line has the equation of x equals a number. Okay, so I can see this goes through -2. So as a starting point, I can say that this is x equals -2. Now I know this has to be an inequality, all right, because there's shading. But these are just some working notes here. Okay, so I also see that there is a solid line. Okay, and the solid line means that the inequality is going to be equal to. All right, now I just need to determine, is it greater than or equal to or less than? So I see that the shading is to the right, and I'm looking at all of the values that have been shaded. Those are all bigger than -2 where the line starts, which means this has to be a greater than. Okay, so the inequality that is graphed here was x is greater than or equal to -2. All right, so first we looked for the equation of the line. We then determined if it was solid or dotted, and then we inspected the shading. Okay, let's do this with a graph that is not a vertical line. Okay, so now we see that there is, a slope and a y-intercept here. So we are going to be looking at y equals mx plus b for this example. Okay, so let's just write down what information I have. So I see I have a y-intercept here. So my b is -2. Okay, and now I'm going to find another point that this line goes through. I see there's one right there, and I'm going to count my slope. So it's up to and over 5. Okay, so now I have a slope, I have a y-intercept. I'm going to determine the inequality symbol and whether it is equal to or not. Okay, so I see that this is a solid line, and a solid line means that it's equal to. Okay, and now I'm going to put my pencil on the line, and I'm going to point to my shading. Point to where the shading is. Well, the shading is above the line. Above the line means greater. So I've just determined that it should be greater than or equal to. Plus I have my slope and my y-intercept. So I'm going to put all of that together. So y is greater than or equal to 5 over 2x minus 2. Okay, and that is the final answer. That is the equation that was graphed here. Okay. All right. That was just a mistake from when it jumped on me. All right, so now this says, from this completed graph, it says name 2 solutions. Okay, so we said before, solutions come from the shading. Okay, so if we pick any 2 ordered pairs, okay, and these must be ordered pairs. Okay, any 2 ordered pairs that are inside the shaded region, that counts as a solution. Any of these ordered pairs. Okay, so possible solutions: 3, 2, 4, -4, 1 comma negative 2, 5 comma 4. Okay, and the list goes on. You can pick any of these points. Okay, those are just 4 possible answers. All right, one more deep breath, because we're going to do a word problem. Okay, so Callie has no more than $24 to spend at the snack bar. Sandwiches are $4 and drinks are $2. Write and solve an inequality that can be used to model the situation. Okay, give 2 possible solutions and explain their meaning, in the context of the problem. Okay, so what's the first thing that we notice here? Anything that you notice, pause the video and write down your observations. Okay, so I see that there's 2 variables. There's sandwiches and there's drinks. So I'm going to need 2 variables. X is sandwich. Y is drinks. I see a turnaround word, no more than $24. Okay, and while I'm at it, I see that sandwiches are $4 and drinks are $2. Okay, so we have a total of $24. Right? No more than is less than or equal to. Okay, if you remember that from 4.1. Okay, so I'm going to translate the sentence here into an equation. Okay, so I have 4x plus 2y is less than or equal to 24. Okay, so however many sandwiches and drinks she buys, she has no more than $24 to spend. Okay, in order to solve this, I'm going to have to graph. Okay, so if I want to graph this, it has to be in slope-intercept form. So I have to solve for y. Okay, and we're going to graph. So you want to create a graph here. All right, so I'm going to begin with my B and move with my slope. So down 2 over 1. Down 2 over 1. Okay, your graph probably looks better than mine if you are using graph paper. All right, so since this is less than or equal to, I'm using a solid line, okay, and less than means I shade below, okay? So use arrows to point below. Okay, so I'm shading. All right, now this is asking me to give 2 possible solutions and explain their meaning in the context of the problem. Well, this is a real life situation. Okay, we're talking about sandwiches and drinks. Right, sandwich was my X and drinks were my Y. Well, that means that I cannot have any negative values for my sandwiches or drinks, which means I need to limit my graph here to only the first quadrant. Okay, so in order to get a solution, we can pick any solution in the shading as long as it is within the first quadrant so that I have positive sandwiches and positive drinks. Okay, so I could have 1 sandwich and 2 drinks. I could have 2 sandwiches and 5 drinks. Okay, there's plenty of other options. Those are going to be my 2. So my solution, I have 1 comma 2, and I said 2 comma 5, and explain their meaning in the context of the problem. Well, what does this ordered pair mean? The x value represents sandwiches and the y value represents drinks. So this is 1 sandwich and 2 drinks. Okay. And this is 2 sandwiches and 5 drinks. Okay. All right, so that is graphing inequalities in 2 variables. I hope that you didn't find that to be too difficult. The word problem we definitely can use some more practice on, and we'll be doing that in class. All right, but for this time, make sure that all of your graphs are complete. Please write down any questions that you have to ask me next time. And